Okay. All right. So I had to restart this thing. All right. So you go which way? To the left. How many units? 2 units. You go 1, 2. Right. So that's how it's going to look. All right. So this is where it was. You go 1, 2. So every point moved which way? To your left. 2 units to the left. Okay. Now on your graph paper, though, you would draw the parent function. So 0, 0, 1, 1, 2, 4. 0, I'm sorry, negative 1, 1, negative 2, 4, correct? So we always those 5 points for x squared. All right, now knowing that I want to graph g of x, which equals x plus 2 squared, that's what you want to graph. So that says I take the parent function and I go 2 units which way? To the left. So you take all these points. So watch what happens. So this point, move 2 units to this vertex, move 2 units to the left. 1, 2. This point right here that I'm pointing to, when I move it 2 units to the left, it becomes this point, right? And then remember that was always this other point. So when I move that other point 2 units to the left, you see you get this point? So this point here, 2 units to the left becomes what? That. And then this point here, 2 units to the left becomes that. And so you just draw your curve. And you get that. Okay? And so always check yourself. So if you go back thinking about this right now, and then moving it 2 units to the left, do I get this? Okay. So on your worksheet, you would label this as x squared, and then this right here would be g of x, which equals x plus 2 squared. Now again, this involved how many transformations? Just one. You took x squared and shifted it which way? To the left 2 units. That's one transformation. All right, now, what if we had this? Okay, what if we had g of x equals this? Okay, there's an order in which you have to do the transformations. The previous two, it did not matter. Because how many transformations were involved? Just one. Here, there's going to actually be 3 transformations. You have what kind of shift? Right here. Horizontal. You have what kind of shift? A vertical. Now, this is what kind of transformation? Nope, that's called a reflection. Yeah. I wonder how many of you remember that word from those videos? Reflection. That's a reflection about, and it's a reflection about which axis? The x-axis. Okay? So basically what that means is this. So this is what I mean by reflection. So if I want to graph g of x, which equals negative x squared, okay? If I want to graph that, first of all, I had to graph x squared. That's this. And then the negative x squared, if you think about it, if x is 1, what's 1 squared? And so this becomes a what? Negative 1. So instead of 1, I'm going to have a what? Negative 1. So all of these points are reflected about the what? X-axis. And hopefully it makes sense to you because if you think about this in terms of a t-table, if x is 0, what is this right here? 0. If x is 1, now remember for the parent function, when x is 1, what's my y value? 1. For negative x squared, what does my y value become? What do you notice about 1 and negative 1? They are what? Opposites. They're reflections about the x-axis. They're symmetric about the x-axis. If x is 2, when x was 2, what was my y value right here? 4. When x is 2 here, what's my y value? Negative 4. So basically, this y value, you reflect about the x-axis, and you get a negative 4, correct? So if x is, let's say, negative 2, for x squared, what was the negative 2 squared? Nope, I'm sorry, you're right. Yep, 4. For negative x squared, what does it become? Negative 4. So you see it's a reflection about the x-axis. So this point here, so basically what's happening when you take this transparency and you reflect it about the x-axis, you get this, right? So you take this. What do I do to this graph? Reflect it about the x-axis. I get that. So instead of going up, it's going to go what? Down. Okay? So reflect it about the x-axis. Now, remember what's happening is this. So here's your parent function. This is your parent function. You see your parent function? And what I did was I took this parent function and did what to it? Reflected about the, just don't use the word flip, you guys say reflect about the x-axis because it's also reflecting about the y-axis. But for that, we're reflecting about the x-axis. And so notice when x was 1, what does it become now? Negative 1. When x is 4, what does it become? Negative 4. When x is negative, positive, I'm sorry, when y is positive 1, what does it become? Positive 1. When y is positive 4, what does it become? Yeah. So the x values stay the same as the y values that became opposites. So you just take the positive 4 becomes a negative 4. A positive 9 becomes a what? Negative 9, and so on. All right. So when you graph it on paper, though, you say, you reflect this point about the x-axis, you have that point. Reflect this point about the x-axis. And all you got to do is look at your y value. If this y value, let's say, is 7, then this y value has to be what? Negative 7. But it's not 7, it's 4. So this has to be a what? Negative 4. This y value is 0, right? What's the opposite of 0? So it stays there, right? This y value is what? 1. It becomes what? You can see it reflected. And then this is 4 becomes a, and you just connect them, and there's your transformation. So this is g of x equal negative x squared. All right, now what we're going to do, though, is graph the one we just saw. Now, there is an order in which you have to do this. Now, there's also called stretching and shrinking. There's something called stretching and shrinking. We're not going to do that in this lesson. It's not in my math lab, so I'm just going to skip that for right now. And on the final, they don't talk about stretching or shrinking. It's just this stuff here. So let's go back to this one. How many transformations are here? You got to tell me what they are. One of them is a what? Horizontal shift. The other one is a what? Reflection. The other one is a what? Okay, that you have to be able to recognize. Now, the order in which you do the transformations are these. You have to do a horizontal shift first. Do one horizontal shift first. The second one is the reflection. And you always do the vertical shift last. If you did the vertical shift first, you would get a different graph than what this really is. So you must do it in that order. Okay, now on the worksheet, it said If you look at the worksheet that you picked up, it said, what was the first one? It said something about state the parent function. What is a parent function? So what is the parent function? All right, but you got to, don't just say x squared, you got to say f of x equal what? Because I think it says, what is the parent function f of x, correct? You got to look at that worksheet that you picked up. So you got to say f of x equal x squared. So then the second thing said, list the transformations. All right, list the transformations. And so you're going to say the first thing, remember the first thing is what kind of shift? Horizontal. So you're going to say you're going to take x squared and then do what to it? Don't just say move it left. I want you to use those words. You're going to say what? Shift horizontally. How many units? How many units? 3. Nope. To the right. See, remember, it's got to be x minus h. H is what here? 3. Now, you do agree that's vertex form, correct? What's a vertex from the previous lesson? 3, negative 4. That's a vertex. So just remember that it's x minus h. So it's counterintuitive what you would think. So don't say 3 units to the left because it's negative. You got to think the opposite of what you just thought. So it's actually 3 units which way? To the right. So that does confuse people. So try and do the best you can with remembering the correct way. But all you have to do is just remember these are all quadratic functions. So you just got to remember that the vertex form is x minus h. And what's h here? A positive 3. That's what h is. So you're going to take x squared, you shift it horizontally 3 units to the right. Then you're going to do what? Then reflect about the x-axis. And then you're going to do what? Okay, so then shift vertically. Oh, not right. When you go vertical, you're going up or down. Uh-huh. Yes. Well, suppose you suppose you did do it wrong. Okay. So let me finish this and then I'll show you why. Okay, let's do it this way. All right. So you shift vertically what? Down. How many units? 4 units. Okay, and then I think the C port was graph G of x. Graph f of x and g of x. Okay. All right. So you're going to graph your parent function. What's the parent function? All right. So remember your points. 1, 2, 3, 4, and 5. There's your 5 points. Okay, so that's f of x right here, correct? Y'all agree? All right. So then in your mind, you're thinking about this. So I shift horizontally which way? To the right 3. So 1, 2, 3, and then what? Nope. You got to reflect. And then down 4. 1, 2, 3, 4. Okay? So that's what your final graph should be. That's what it should look like. So having something like this does help. So you go to the right 3. 1, 2, 3. Then you reflect right. Your vertex is still at this point 3, 0. And now you go where? Down 3. All right, so I'm sorry, down 4? Okay, down 4. So look, here's how you would do this. Okay, take this point here first. Which way do I go? To the right, 3. 1, 2, 3. Don't put a dot there, just put this over it. Now what's the next thing I do to that point? Reflect it. So this 4 becomes a negative 4. We can do it again. 1, 2, 3. So now a negative 4, right? So right here, correct? Now do what to that? Go down 4. 1, 2, 3, 4. You see at this point now? All right. So 1, 2, 3, 4. 1, 2, 3. I'm sorry, and then reflect it, and then go down 3. It's harder to do this with just 2 graphs. So if you need to draw all those transformations, then do it. For some people, it might be easier to do. So what will be the first thing I need to do? Well, we already did that. What's the next thing? Move it horizontally to the right. How many units? 3. 1, 2, 3. 1, 2, 3. Right? 1, 2, 3. Y'all agree? 1, 2, 3. 1, 2, 3. Okay. So now I'm here. Now what do I do to this? Reflect it. So I reflect it. 4 becomes a negative 4. 1 becomes a negative 1. 0 stays 0. 1 becomes a negative 1. 4 becomes a negative 4. Now what do I do to this? Yeah, so use a different color if you got to, because there's too many things here. So every point's going to be shifted down how many units? 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Until you get this. So this right here is g of x, which equals what? Negative x minus 3 squared minus 4. So if you need to draw the other 2 transformations, then go ahead and do it. It may help you. You can use a different color, yeah. So you have this. So you got to label the parent function. So you got to say f of x equal what here? X squared. And you have to label the final function, and the final function is this. And it kind of makes sense because remember what you did. You went 3 units to the right, then you reflected about the x-axis, and then you shifted vertically down 4 units. Okay? All right. So if you have access to this, then use it. Okay? Yeah, hold on. Let me try and finish this, and we will. Okay, so all right, so that's going to take care of the x squared. Now, once you got the x squared, if you remember the video, once you looked at the video, and I'm sure there's probably about 2 of you that did, the rest of you didn't. But once you look at the video, then the other part's fairly easy because it's the same idea. It's just that the shape looks different. What's the shape of an absolute value? That V. Okay, the V. All right, so quickly take 5 minutes.